This is the second part of our lesson on dividing powers. We just learned that when you are dividing two powers with the same base, you leave the base the same and subtract the exponents. So our first question here says simplify using exponent laws. That means we're going to have a power as our answer versus a number. And I have 20x to the power of 30 divided by 5x to the power of 10. So when they have the same base, like x to the power of 30 and x to the power of 10, I can use exponent laws on those parts because they have the same base. But if I look at the 20 and the 5, the 20 and the 5 are not the same. They're not the same number. It's not like I had 5 and 5 or 20 and 20. They're two completely different numbers. So they're not the same number, and they don't have a visible exponent. They would have a little invisible 1, but we're going to just ignore those for right now. So when you have just a number without an exponent that you can see in front of a variable, that means it's a coefficient. And if it's a coefficient, you can multiply or divide or do whatever it is you need to do with those numbers. So here, I am doing 20 divided by 5. 20 divided by 5 is 4. And then when I go to do the x's have the same base, so I am going to try to use my exponent law. So the base stays the same, and then we subtract our exponents. Now, do you have to show that, or could I just calculate it? You could just calculate it, and that would be okay. 30 take away 10 is 20, so this is 4x to the power of 20. I have one more example to do where we have a mix of coefficients and variables. I have 35, a to the 25, b to the 19, divided by 7, a to the 8, b to the 18. So if I look at just the numerator, 35, a, and b, those are all different numbers or variables. It's not like I have two things that are the same base being multiplied or divided, so I can't really do anything with that. Same thing on the bottom, 7, a to the 8, b to the 18. These are all unique bases. They're all different. I can't really do anything with them. But I can divide, and we're going to divide like things with like things. I'm going to divide the b's with the b's, and I'm going to divide the a's with the a's. And then the 35 and the 7 do not have exponents, and they are sitting in front of variables, which means they are coefficients. So I'm going to do the 35 and the 7, the numbers, or the coefficients with the coefficients. So I'm going to start with 35 and 7. So it is easy to get a little confused and think maybe you should subtract, but it is just division. 35 divided by 7. So 35 divided by 7 is 5. When I go to do the a's, they have the same base. So a to the 25 divided by a to the 8 is going to be a to the power of 25 minus 8. So 25 minus 8 is 17. So that's going to be a to the power of 17. And then b to the 19 divided by b to the 18. They have the same base, so I'm going to write down the b and then subtract the exponents. 19 take away 18 gives me b to the power of 1. So I have 5, a to the 17, b to the 1. Now, I do just want to say that this power of 1, the 1s are very shy and they don't like to stand out if they don't have to. You could write this as 5, a to the 17, and then just b. But I'm okay if you want to write the 1. If you don't want to write the 1, that's your choice. And that's how you do exponent laws when you have coefficients.